The client sends the request in this format and the server replies with a positive response, confirming that all fault information linked to the DTC group FFFF33 has been erased. Last video, we explored the write memory by address 3D service in detail. In this video, we'll move on to another very important UDS service, Clear Diagnostic Information 14 service. So, what's the purpose of this service? Simply put, it allows a diagnostic tester or client to clear the fault information stored inside one or multiple ECUs. When this service is triggered, the ECU wipes out all stored diagnostic trouble code data, including DTC status bytes, snapshot data, extended data, and other fault-related information like the very first or most recent DTC, special flags, and counters. But here's something important. If the ECU has a mirror memory, which is optional, the DTC data stored there will not be cleared by this service. Now that we know the purpose of this service, let's take a closer look at its request definition. The request begins with the service identifier or SID for Clear Diagnostic Information, which is 0x14. After that, we have an important parameter called groupOfDTC. This is made up of 3 bytes: high byte, middle byte, low byte. Each byte can range from 00 to FF. So, what does this parameter actually do? The groupOfDTC tells the ECU whether we want to clear a specific DTC or an entire group of DTCs, such as powertrain, body, or chassis related faults. Think of it like cleaning up files on your computer. You can choose to delete just one file, similar to a specific DTC, or clear an entire folder, similar to all powertrain related faults. And here's something important. Unlike some other UDS services, this one doesn't use any subfunction parameter. Now, let's see how the ECU responds with a positive response. The positive response only contains the Clear Diagnostic Information Response SID 54, which indicates that the ECU has accepted the request. The ECU sends this positive response once the Clear Diagnostic Information process is finished. Interestingly, it will still send a positive response even if there were no faults to clear in the first place. Following are NRC supported. NRC 13, incorrect message length or invalid format. This NRC shall be sent if the length of the message is wrong. NRC 22, conditions not correct. This NRC shall be used if the internal conditions of the server prevent clearing of the DTC related information from server. NRC 31, request out of range. Sent when the groupOfDTC parameter is not supported. NRC 72, general programming failure. Sent when the server detects an error while writing to a memory location. The diagram shows the order of evaluation for different negative response codes, NRCs. The first check is for NRC 13, verifying that the request length is exactly 4 bytes. Next is the active session check, which ensures that the DID is supported in the current diagnostic session. If this fails, the server responds with NRC 31. Then comes the precondition check. If the required preconditions are not fulfilled, the server sends NRC 22. After that, the ECU performs any manufacturer or supplier specific checks if defined. Finally, the ECU checks whether the data is correctly written into server memory. If this fails, it returns NRC 72. If all these checks pass, the server sends a positive response for the requested service. Now, let's understand Clear Diagnostic Information through an example. Imagine the client requests to clear the DTC group FFFFF33. The client sends the request in this format and the server replies with a positive response, confirming that all fault information linked to the DTC group FFFF33 has been erased. With this example, we've wrapped up our detailed look at the Clear Diagnostic Information 14 service. In the next session, we'll move on to another important one, the Read DTC Information 19 service. See you in the next video. Thank you for watching.